Hi, today we're going to take a look at the basic power rule of the derivative. Now we've been doing the definition for quite some time now, so it's going to be a nice little change of pace right here. And the power rule, very simple, is if you have a function, like let's say you have f of x equals something like x to the n. To take the derivative, all we have to do is drop the power. The n goes to the front, and we're going to multiply that by x, the function, and we're just going to subtract 1. Many of you might have recognized that little pattern after doing the definition for quite some time. And this is our basic power rule. Now, other derivative that we're going to be taking a look at today are some simple ones, like the derivative of the sine of x with respect to x. Remember, this is the form, the change in y with the change in x. This is just the derivative. The derivative of sine of x becomes the cosine of x. And the derivative of the cosine of x becomes negative sine of x. So let's go and take a look at a few examples here. Before we do that, other ways we can write the derivative. We already know we have f prime of x. We also have y prime, but another favorite of everybody's is this dy dx. Now the reason we like dy dx so much is because it literally says on the top, that's the change in y values over the change in x values. Now it might sound familiar because we know delta y over delta x means the same thing, but the only difference is delta for us means you're going to be finding the slope of a secant line. In other words, this requires 2 points, where the dy dx requires only 1 point. This is the derivative. So let's take a look at some examples. When we're taking derivatives, we're going to use our power rule today, so it's very simple to do. So I'm going to go f prime of x. To show that I'm taking a derivative, I use the primes. I drop that 3. I'm going to drop my power because that's what my power rule says to do. Oh no, there goes my light. Let me turn it on real quick. There we go. We're going to drop that 3, so this becomes 3x, and then the rule says to subtract 1. So I minus 1 from 3, and I get 2. And there is our derivative. Very easy to do. For example, let's take a look at number 2. Now for number 2, this is a little different. It's not a power rule. It doesn't follow my power rule because there's no power. So I'm going to write the square root as a power. I can write that as x to the 1/2. And now when I take the derivative, I'm going to go y prime, because now I'm taking the derivative, and I can use my power rule. Bring the 2 to the 1/2 to the front, and we get x to the negative 1/2. Now we do have a quick rule. No negative exponents. We don't like negative exponents here, so my rule, I have to get rid of that negative 1/2. So I can rewrite this. The derivative equals 1 over the 2 stays on bottom, and I bring that x to the 1/2 on bottom as well. You could write this as 1 over root x as well if you like. Either one's fine. For number 3, same thing. But again, this is not really a power rule yet. So I'm going to rewrite this as well as t to the negative 4. So take a look. We're going to write everything. We want a power on top. We don't want anything on the bottom yet. So now when we take the derivative f prime of t, drop that power to the front, negative 4 t subtract 1 to the negative 5. And again, get rid of that negative exponent. So f prime of t will equal, now be careful, the negative 4 stays on top. The t only goes on bottom. The negative power only belongs to the t. So the t to the 5th goes on bottom, and there's our derivative. There's a shortcut for a lot of these as well. Most of you will figure it out. I don't have to necessarily teach it. Most of you will figure it out on your own. So let's take a look at number 4 through 6 here real quick. Very simple, just a straight up power rule. So when I take the derivative, f prime of x, I'm going to get 12, because I'm going to multiply. 3 times 4 is 12, x squared minus, if I bring the 2 down, I got to multiply the 2 by that 5. So that becomes minus 10x to the 1st. Subtract your power. Oh no, there's no power on the x here. Give it 1. Literally 1. Drop it like it's hot. We get plus 7x to the 0 power. You don't have to write that. We're going to shortcut this in just a few moments. Next is the 3. Now the 3 is a constant. Now, it's also like if you think of the equation, it's like y equals 3. This is a horizontal line. Its slope is 0. So the derivative of 3 is just 0. So that's kind of a rule for us. It's called the constant rule for derivatives. And that says if y equals c, where c is a constant, then the derivative is 0. So I can rewrite my derivative now as f prime of x equals 12x squared minus 10x, I don't need to put the 1, plus 7, I don't need to put the x to the 0, I don't need to put that plus 0 there at the end. And there's our derivative. Alright, we're not from there. For number 5, now number 5, we're going to learn something later on called the quotient rule, and you're going to forget about how I teach number 5 here. But I'm going to show you a shortcut real quickly for this. You can use an algebra trick that allows us, if we have a common denominator, if we have a common denominator, we can split a fraction. And I can do that by rewriting. It says y equals 5x to the 5th over x minus 3x to the 4th over x plus 4 over x. Are you over your x? Oh. Alright. And I can continue simplifying this as y equals 5x to the 4th minus 3x cubed. Now I am going to bring the x up here. It's kind of like what we did for number 3 up here, where we brought that power up. We're going to bring that power of x up, and we get 4x to the negative 1. And once we get here, the derivative is quite simple. Now I'm going to go crazy. You don't know me. I'm going to use that dy dx. Drop your power. I'm going to take the 4 multiplied by the 5. I get 20x cubed minus 9x squared, and be careful, minus 4x to the negative 2. I still have to write this as a common denominator. I don't like that negative exponent, so I still have to rewrite this. So when I write my final answer, I'm going to go 20x cubed minus 9x squared minus 4. Now the x is going to go on bottom here, but only under the 4. You're going to want to put over everything. Don't do that. Avoid that natural urge. And there's your derivative. Most of you will skip straight from here to here, and then from here to your answer eventually. So it just takes practice. It's pretty easy. So try this one again if you want to. Now for number 6. Okay, now there we go. For number 6, we're going to learn something later on called the chain rule, in which case we'll never use this method here again either. So that's going to be later on though. So for now though, to take the derivative, we are going to expand this. That power 2 tells me I have to expand this. Alright, that's like saying 3x plus 2 times 3x plus 2. And if we expand it, we get 9x squared plus 6, so plus 12x plus 4. Now be careful, this is not the derivative. Some people are like, oh look, I took the derivative. No, you just did some algebra 1 stuff. Now comes the derivative, our power rule. Did you drop a power? Nope, then you didn't take a derivative. Drop the 2, we get 18x plus, again there's a 1 there, plus 12. And like I said earlier, because it's a 0, you don't need to put x to the 0. So you can just stop right there. And there's number 6 for us. So let's take a look at some examples on how we can apply these. Very easy to do. Oops. Oh no! Sorry. I almost forgot. Let's take a look at some trig ones before we do that, okay? Let's take a look. So let's get triggy with it. So for number 7, we have this function x squared plus 5 cosine x, and we want to take the derivative. So I'm going to start by identifying it as a derivative. Now the first one, 6x squared, that's just our straightforward power rule. I get 12x to the first plus, now the 5 is a constant, we really don't worry about it, but it's the derivative cosine that we need. And if you remember earlier, we said that that was negative sine of x. There's a derivative cosine. You can leave it like this. I don't like people to simplify. Don't be a hero, I tell them. But this one's not too bad. We get 12x minus 5 sine of x. And there's your derivative. Very easy to do. Alright, number 8 is always kind of scary because we use the letter J. I'm just teasing. No, it's just pi. People always get scared of pi. Don't worry, pi is just a constant. So when I take the derivative, the first one's pretty easy. we're going to get pi. The derivative of sine of x is just cosine of x minus, this becomes just 3 pi squared, and the derivative of cosine is negative sine of x, and here's the part that gets tricky, minus e is a constant. AP is going to try to trick you up sometime. So its derivative is 0. So when you write out your final answer, we get pi times the cosine of x minus, or plus, that's negative 3 pi squared sine of x. And there's your answer. Very simple to do. I like derivatives. The next one, look at this, finding a tangent line. Now there are two things we need for a tangent line. The first thing you're going to need is a point. Now we're lucky. We'll find the tangent line of this function, 2x cubed minus 7, at this point 1 negative 5. So, they already gave me the point, so that part's easy. All we have to do now is find the slope. Well, what finds slope? But the derivative, using your power rule, 6x squared. The 7 becomes 0, so don't worry about it. So to get the slope, remember, this is not the slope. If you do this, y plus 5 equals 6x squared times x minus 1. You get no points for that. That is not the slope. This is a slope finder. We've talked about that many a times. That is called the slope finder. To get the slope, we have to plug in our x coordinate, which is 1. And that gives me 6 times 1 squared, which is 6. That's my slope. So my equation for my tangent line, y minus y1 equals m times x minus x1. We get y plus 5 equal to 6x minus 1. And that's your tangent line. You can solve for y if you want to, but actually we really like this one because if you remember from pre-cal, this is change in y, m, and that's your change in x. It's kind of our derivative right there later on. Alright, the next one says, find out where the horizontal tangents occur for this function, x cubed plus 4x squared minus 7. Horizontal tangents. This is where the slope is 0. So to find out where the slope is 0, we have to take the derivative, f prime of x. Easy enough. 3x squared plus 8x, and we just set that equal to 0. And here I can factor out an x. I get 3x plus 8, and I get x equals 0. X is negative 8 over 3. Now, why do we like this? Well, this can actually help us graph it at negative 8 over 3 and at 0. Well, we know from pre-cal experience that anything with a cubic graph looks something like this. Starts negative, ends positive. So I know here the slope is 0 and here the slope is 0. So if I'm going up, I can go up. I know the slope turns around, and at the 0 also turns around. Missed it. And we get the basic idea what the shape looks like. That should be my 0 there. Totally missed that. Sorry. And we get the basic idea what the graph looks like. Alright, our last one is a very big one for us. So you may want to pause this one every once in a while to watch it. Tangent. Find k so that f of x is tangent to y. So let's talk about what it means to be tangent. When you're tangent, that means you're going to have the same value. Remember, if a function is tangent to a curve, at this point, they share a common point and a common slope. So they're going to have the same value, and they're going to have the same slope. So if we deal with the value, we're really saying that the function equals the line. So we're saying that f of x has to equal y. If they're the same slope, that means we're saying that their derivatives are the same. So I can set this up. Well, value-wise, this is pretty easy. We're going to say k minus x squared equals negative 6x plus 1. If their derivatives are the same, well, be careful, k is a constant. I get negative 2x equals negative 6. Now I want to find k. Well, this isn't that bad to do, because if I knew what x value was, I can find k. But the slope tells me that x is just going to be 3. And I can just plug it in. This is a big thing for the AP right here. So we can get k minus This 3 squared is 9 equals negative 18 plus 1. So solving it, k minus 9 equals negative 17. Therefore, k equals, add 9 to that, we get k equals 8. All right, well, I hope you enjoy these, and I hope they help you, and I'll see you guys later. Bye-bye.